The incomprehensible scale of cosmic giants. In the bewildering immensity of the cosmos, where our perception of scale is constantly redefined, there exists a class of objects so monumentally massive they force a fundamental reassessment of physical limits. These are not merely large stellar remnants or dense galactic cores. They are singularities of infinite darkness, wrapped in searing halos of energy that dwarf entire galaxies. Among this exclusive group, one entity stands out as the undisputed champion of the early universe, TON 618. This hyperluminous object is not merely a supermassive black hole. It is an ultramassive black hole, a titan whose very existence challenges our models of cosmic evolution. Its location, near the celestial boundary of the constellations Canes, Venatici, and Coma Berenices, marks a point in space where gravity reigns supreme, dictating the fate of colossal volumes of matter and energy. From faint star to cosmic beacon, the history of discovery. The discovery of TON 618 is a classic narrative of astronomical misidentification and subsequent revelation. Its existence was first catalogued in 1957 by astronomers working at the Tonantzintla Observatory in Mexico. At that time, its light, though energetic, appeared faint and nondescript when viewed through the limited instrumentation of the era. The object was initially logged simply as an unremarkable, slightly blue star, a common finding in vast sky surveys. It took years of technological advancement and dedicated spectroscopic analysis to unveil its true, terrifying nature. In the 1,960 seconds, as astronomers began to systematically investigate stellar objects exhibiting unusual spectral properties, TON 618 was subjected to detailed study. The resulting spectra did not show the characteristic absorption lines of a nearby star. Instead, they revealed extremely broad, bright emission lines, most notably from hydrogen. Crucially, these lines were severely redshifted, a phenomenon where the wavelength of light is stretched due to the universe's expansion, much like an ambulance siren dropping in pitch as it moves away. This dramatic redshift, later measured to be at a value of approximately 2.2, instantly placed the object not in our galaxy, but at the very edge of the observable universe. It was not a faint blue star, but the hyper-energetic, fiercely blazing core of an ancient, distant galaxy, a quasar. The zenith of distance, a window into cosmic genesis. The measured distance of TON 618 is perhaps its second most staggering feature. With a redshift value of approximately 2.2, relativistic cosmological calculations place this object more than 18 billion light-years away from Earth. This immense separation carries profound astrophysical meaning. When we observe TON 618 today, we are witnessing an event that occurred approximately 12.1 billion years ago. This means the light we are currently detecting began its journey when the universe was less than a quarter of its current age, estimated to be around 13.8 billion years old. TON 618 is thus a time capsule, offering a direct glimpse into the epoch of cosmic genesis, a tumultuous period when the first generations of stars were igniting and the earliest galactic structures were undergoing rapid, violent formation. Due to this extreme distance, direct, resolved imaging of the host galaxy is impossible. TON 618 reveals its presence solely through its intense, blinding light, a beacon visible across the entire panorama of the observable cosmos. The mechanism of radiance, fueling the quasar engine. TON 618's spectacular luminosity identifies it as a quasar, the most powerful class of active galactic nuclei. Quasars are, fundamentally, the engines of young, active galaxies, powered by colossal supermassive black holes that are voraciously consuming surrounding matter. The process is one of astonishing efficiency and violence. Vast clouds of gas, dust, and disrupted stars are drawn inexorably inward by the black hole's immense gravitational field. As this matter spirals closer, it accelerates to relativistic speeds, a significant fraction of the speed of light, and organizes into a flattened, rapidly rotating structure called an accretion disk. Within this disk, the density and velocity gradients are extreme. Friction, differential rotation, and intense gravitational shear cause the gas to violently rub against itself, converting gravitational potential energy into thermal energy. This process generates temperatures far exceeding those found at the surface of any star, often reaching millions or even billions of Kelvin. At these temperatures, the superheated matter radiates across the entire electromagnetic spectrum from low-energy radio waves up through visible light and culminating in high-energy, deadly X-rays and gamma rays. This luminous beacon is so powerful that it easily outshines the collective light of the hundreds of billions of stars in its entire host galaxy. The total energy output of tons 618 is equivalent to the combined light of 100 trillion suns, that is, 10 raised to the power of 14 solar luminosities. To put this into perspective, if tons 618 were hypothetically placed at the center of the Milky Way, its light would instantly overwhelm every star, appearing approximately 23 times brighter than a full moon, and effectively eliminating the concept of a night sky on Earth. It is the purest example of gravitational power transformed into light, rendering a single, distant point of space the brightest persistent structure in the universe. The destructive engine, unveiling the ultramassive core. The astonishing light output of 20N 618 is merely the observable consequence of an engine of unimaginable gravitational force. Using sophisticated techniques that analyze the extreme broadening of the emission lines, a measure of the high velocities of gas circling the black hole, known as the virial method, astronomers have estimated the core mass of 2N 618 at an astounding 66 billion solar masses, or 6.6, multiplied by 10 raised to the power of 10 times the mass of the Sun. This figure places ton 618 firmly in the category of an ultramassive black hole, an object whose mass transcends even the definition of a typical supermassive black hole, which usually range from a few million up to a few billion solar masses. For comparison, the supermassive black hole at the heart of our own Milky Way galaxy, named Sagittarius A star, possesses a mass of approximately 4.3 million solar masses. Ton 618 is therefore over 15,000 times heavier than Sagittarius A star. Its gravitational influence is not just localized to the core of its host galaxy, it defines the structure and evolution of the entire surrounding region. The spheres of no return, the event horizon, and the singularity. The size of a black hole is not defined by its physical matter, but by the gravitational boundary from which nothing, not even light, can escape. This boundary is the event horizon, defined by the Schwarzschild radius. This radius is determined by a fundamental relationship in physics. The Schwarzschild radius equals 2 multiplied by the gravitational constant, multiplied by the black hole's mass, and all divided by the speed of light squared. Because the radius is directly proportional to the mass, ton 618's extreme heft yields an event horizon of truly cosmic dimensions. Given the staggering 66 billion solar mass core, the event horizon of ton 618 is a sphere of absolute darkness spanning an unimaginable 400 billion kilometers across. To properly visualize this scale, our entire solar system, extending past the orbit of Pluto, would vanish effortlessly within this boundary, leaving vast, empty space. This is not merely a dense object, it is a macroscopic warp in the fabric of spacetime itself. Standing near its edge would reveal the bending of physics in real time. Light, instead of traveling in straight lines, is forced to follow the severe curvature of spacetime. This effect, known as gravitational lensing, would create a glowing halo around the black hole shadow, composed of photons trapped briefly in highly unstable orbits before either escaping or beginning their final, inevitable plunge across the event horizon. Relativistic effects, time dilation, and gravitational redshift. The extreme gravitational field of 20N 618 dramatically affects the fundamental laws of physics, most notably impacting time and light through Einstein's theory of general relativity. First, the gravitational field causes gravitational time dilation. Clocks tick significantly slower the deeper they are within a massive gravitational well. For an observer near the event horizon of 2N 618, seconds would stretch into years for any distant observer outside the system. An object approaching the black hole would appear to a remote observer to slow down, freeze, and become eternally suspended at the brink of the horizon. their descent into darkness infinitely deferred. Second, light itself is affected by the loss of energy as it climbs out of the deep gravity well, a phenomenon called gravitational redshift. Radiation emitted close to the horizon would have its energy severely stretched to longer, darker wavelengths. To an observer, once bright, high-energy light would fade into a deep crimson or infrared, as if the black hole was actively bleeding the visible color and energy from the universe around it. Beyond the event horizon lies the singularity, a point of infinite density and zero volume, where the current body of physical understanding collapses completely and spacetime itself ceases to exist as we know it. The relativistic jets, shaping galaxies. The violence of the quasar is further amplified by powerful magnetic fields within the accretion disk. These fields coil, twist, and snap, acting like a cosmic engine to launch colossal, highly collimated streams of plasma known as relativistic jets. These focused streams blast out from the black hole's poles at velocities approaching the speed of light. Each jet is a physical structure of staggering magnitude, stretching for millions of light years, a span greater than entire galaxies, and carrying sufficient energy to fundamentally alter the course of galactic evolution. This energy feedback mechanism can blow away gas and dust, heating the interstellar medium and effectively halting star formation in the host galaxy, a process known as quasar mode feedback. 618, the paradox of early growth. Perhaps the greatest scientific mystery surrounding 618 lies not in its present size, but in its age. Supermassive black holes are generally believed to evolve slowly, beginning as smaller, stellar remnants or through the direct collapse of primordial gas clouds, growing gradually over billions of years by consuming matter and merging with other black holes. However, 618 challenges the very limits of these evolutionary theories. To have amassed a colossal mass of 66 billion solar masses so early in the cosmos's history, when the universe was only about 1.7 billion years old, it must have grown at an extraordinary, unprecedented rate. It either started from an unusually massive seed black hole, perhaps resulting from the direct collapse of a primordial gas cloud of 100,000 solar masses or more, or the feeding conditions in the early universe were far more extreme and efficient than current astrophysical models have accounted for. The existence of 618, alongside other similarly massive, high redshift quasars, fundamentally pushes the boundaries of our theoretical understanding of black hole formation and growth, forcing scientists to rethink the physics of the nascent universe. The Destructive Guide. A window into the past. Despite its destructive power, quasars like 618 are invaluable to cosmology. Because their light travels across billions of years, it interacts with the diffuse, pristine gas filling the intergalactic void. By analyzing this ancient light, astronomers can use the absorption features, known as the Lyman alpha forest, to measure the chemistry and composition of the early universe, trace the distribution of matter, and study precisely how galaxies grew and evolved during the first billion years after the Big Bang. 618 is thus a profound paradox. It is both a titanic destroyer of cosmic material and a critical guide, illuminating the hidden structures and processes of the nascent universe. In gazing upon this ultramassive black hole across more than 10 billion years of distance, we glimpse the simultaneous terror and the profound, humbling wonder that defines the cosmos.